Hi everyone, this is the notes for section 5.2. So in this section, we're going to be verifying identities. So another way to say that is basically we're proving that one side of our identity is equal to the other side. But it's not the same as solving an equation, so we can't do any of those things we would do to an equation, like add something to both sides or multiply both sides to something. We can only manipulate one side using other identities and plugging stuff in or factoring. Here's a list of tips that can help you be able to solve those. So just remember, it's not the same as solving an equation. So this is one of my favorite things that we do in Trig, but it's also one of the hardest, so it's going to take a lot of practice. So just be warned. Okay, so our first thing we're going to do is just to rewrite our two equations in terms of sine and in terms of cosine, because this Pythagorean identity we use all the time, like I said in the last video. So we need to be familiar with its different forms, because sometimes it'll give us, we'll be needing it, but it's like solved for sine or solved for cosine or something. So let's take our Pythagorean identity and solve it for cosine, and then we'll solve it for sine. So that way we're used to looking at its different forms. So if I want to get cosine by itself, I would subtract that sine squared. So one other form is that cosine squared is equal to 1 minus sine squared. So if you ever have a cosine squared and you need to change it to a sine squared, this is what it would be equal to. If you just have a cosine and you need a sine or a sine squared, then we could take the square root of both sides. So just cosine would be equal to the square root of 1 minus sine squared. Okay, so that's two different versions of this same identity, solved for cosine squared and solved for cosine. Remember that when we take square roots, we put the plus or minus. And this is as simplified as you can get this. It does not equal 1 minus sine. You can't take the square roots of sums, so you have to leave it just like that. Okay, so let's do the same thing, but solve it for sine. Okay, so if I want to get sine by itself, I'll subtract the cosine to the other side. So we would have sine squared theta equals 1 minus cosine squared. So this is our identity that relates sine squared and cosine squared. Like I said, if we need to replace sine squared, this is what we would replace it with if we want a cosine squared. And then we can do the same thing and take the square root. So it would also equal, sine would equal the plus or minus the square root of 1 minus cosine squared theta. So those are just different versions of that one identity. And we can do this with all of our identities. We're not going to now, but there's a lot of different ways you can manipulate them and change things around to look at them, even though they're still keeping what they're equal to. Okay, so let's look and see what we got. Okay, so our first one says to verify it by working with one side of the equation. So that means we want to change one side to make it equal the other side. And one of your tips on the front, I think it says tip number 2, to rewrite the more complicated side. Sometimes I know when you look at it, you're going to be like, well, I don't know what side is more complicated. Usually it's the left side that we work with, but it doesn't have to be. You could do either side and then try to get it to look like the other side. But for this problem, obviously this side is way more complicated looking than that side. So we want to change this so it equals 1. So one tip is to always just make everything sines and cosines, which is why we practiced that last lesson. So if we converted everything to sines and cosines, then we'll have some kind of common functions there. So that's what I would do here. Change all of our functions to sine and cosine. So cotangent is also, if we look on our identity sheet, cosine over sine. We have a sine already here, so that would be like sine over 1. And secant is 1 over cosine. So this is still equal to what we had. So from here now, can we simplify this? Good. We can cancel out those signs because we have 1 in the top and the bottom and the cosines. So all we're left with is 1. So 1 is equal to 1. We did it. So when I do them, and usually what I do is I will put a check at the end to say, like, here I am, I'm done. This is it. So that would be it. As you notice, like, I didn't put an X for each one of the functions, even though I should technically. Just like I said in the last video, it just gets tedious. So I just make sure I write them back in at the end. So I'm not going to mark you off if you don't write them in through your work, as long as they're there at the end. And you remember that they should be there. The only time that I do write them is if it's a different value. If, for x, like if one is cotangent of 2x and that was sine of x, then you need to keep writing them so you know that they're different. But we're not going to get that until another lesson or two. Okay, so let's take a look at our next one. So for this one, I would say the left side is a lot more complicated again. So what, if you look at that, what do you think we could do? How can we get this side to turn into a cosecant? Remember, cosecant is 1 over sine squared. Well, I know that cotangent is cosine over sine. So if I change this, then I kind of have my sine squared in the bottom. So that's what I'm going to do first. I'm going to change cotangent squared to cosine squared over sine squared. So we kind of have part of what we want. We want 1 over sine squared. But we need to get rid of that cosine and that part. So I changed the cotangent to what it's equivalent to. Now what about that parenthesis? Is tangent squared plus 1 equivalent to anything? Go ahead and look on your identity sheet. So if we look, we see that tangent squared plus 1 is equal to secant squared. So I'm going to change that to secant squared. And then we know that secant squared is equal to, 1 over cosine squared. So if I change that to 1 over cosine squared, now just like the last one, we can cross out those cosines. So I have 1 over sine squared left, which is equal to cosecant squared. So our last step is stating, this side is equal to what we had that side and bring it down. I mean, we should rewrite that every time, but I usually don't. I just write it down at the last step. Okay, so let's take a look at our next one. Okay, so I'm going to work with the left side. We could try to start with this side. It would be harder though, but I want you to keep in mind what's over here. Okay, we have cosines. It's 2 parentheses, so that means it kind of could be foiled. If you get stuck, I would foil this and see what you get, and then kind of work here to get it. Or sometimes we do use 2 sides. Most of the time we stick to one side, but if you work on the other side and see kind of where you need to go, then you can go back to the side that you started with. So again, for this problem, since I know I need cosines, I'm going to change my things that were given to cosines, or sines and cosines, so then we can work from there. So if we change the top, we would have sine squared over cosine squared, and then the bottom is 1 over cosine squared. So if we flip and multiply, we have sine squared over cosine squared times cosine squared over 1. So that gives us sine squared. And remember, I want cosine. So what was our equivalent? Sine squared equals what? Good, that would equal 1 minus cosine squared. And this is a perfect square binomial, so we can factor it. Remember factoring? If we have like x squared minus 9, this is the same thing as x plus 3, x minus 3. Because they're both perfect squares and it's a difference. This is always factors like that if it's something like that. So for this one, 1 is squared and this is squared. So it's a perfect square binomial. It's a difference of squares. So we can factor just like I did on that other one. So 1 minus cosine, and then 1 plus cosine. So now we got it equal. I know it's had plus first on the other side, but that doesn't really matter since they're multiplying. So that would be it for that one. Okay, good job. So let's take a look at this next one. This one's a little bit different, maybe harder than the last one. This involves tip number 5, multiplying by a conjugate. So it helps us give us what we want when we do that. And remember, conjugates were like the pairs with one being plus and one being minus. So like the conjugate to 2 plus the square root of 3 is 2 minus the square root of 3. So those are conjugates. They also come with imaginary numbers, and we're going to use that same idea here with the plus and minus, because if we FOIL those together, the middle term cancels out. The reason we're going to multiply by the conjugate here, or really, I mean, it is the conjugate in the numerator, but what we're trying to get is that denominator. So the denominator of this side and the numerator of that side are conjugates. They have opposite signs but the same terms. So since I kind of, like if you're looking at this and you have no idea where to go, but I see that this is what I want in the denominator, I'm going to choose to multiply the top and the bottom by that denominator. So I'm bringing in the denominator I want. And this is going to help us because when we FOIL out the top, it's going to cancel out some of those terms. Okay, so I'm going to multiply the top and the bottom by secant minus tangent. So we're allowed to do this because it's just like you would do if you're getting common denominators. It doesn't change the value of that side because we're doing it to the top and the bottom. So really, technically, we're multiplying by 1 because if you divide something by itself, it's just 1. So we're not changing any value here, but we're giving us what we want. Okay, so in the numerator, I'm going to FOIL. So we would have secant squared minus tangent squared. If you don't remember how to FOIL, do it on a separate paper and bring it back in. If you still have questions, we can go over it next class. But remember, we times each thing. Okay. So in the bottom, I'm not going to distribute here because I know I want that secant tangent still there. So I'm just going to rewrite everything and keep that there because I know that's what I want. I'm not trying to get rid of it. We did everything we did on purpose to get that there. Okay, so from here, what we need is really to get rid of those secants and tangents. So we want them to be like the same, because now we can't do anything because one's secant, one's tangent, like these ones in the top. So I know that if I look at secant squared, if you look on your identity sheet, we know that secant squared is equal to tangent squared plus 1 or 1 plus tangent squared. So I'm going to replace that. So that equals 1 plus tangent squared So from here we know terms cancel out, and then I have 1 left in the top and then our 2 pieces in the bottom. So I'm kind of look at those pieces that we have left kind of separate. I have 1 over sine times 1 over secant minus tangent. So what is 1 over sine? Very good, that's cosecant over 1. So since that's over 1, I'm going to leave it in the top and put my secant minus tangent in the bottom. And then we have exactly what we wanted. That's it. Okay, so multiplying by the conjugates, I think, is one of the harder types of problems. But again, we did that because we saw what we had here. We had a binomial, and so we multiplied to get that binomial in the other one. And it worked out in our favor because things canceled and then we got it to what we wanted. Okay, so if you see something like that, that's a good method to use. Okay, so let's take a look at our last problem. So this one says to work on both sides of the equation. So when it says that, which isn't very often, we don't do many of these. Most of them are just working on one side. What you're going to do is try to simplify stuff as much as you can, and then try to simplify the other side as much as you can to make them be the same thing. So we're not going to get one side to equal this and then do it on both sides. We're going to get them to equal something else that's the same. So let's start on the left side because that's the side we did all those other ones before. And if we look on the left, we have some cotangents and cosecants. But on the right, we just have sines and cosines. So I'm going to change all our cotangents and cosecants to sines and cosines, and then see where we can go from there. So in our top, we have cotangent, which is cosine over sine, minus cosecant, which is 1 over sine. And in the bottom, we have another cotangent minus or plus a cosecant. Okay, so we do have common denominators in the numerator and in the denominator, so we could add those fractions, flip and multiply and do all that, but a shortcut here is to multiply by that denominator because that'll help us cancel out our fractions and fractions. Okay, so I'm going to multiply the top and the bottom by sine because, again, I'm just multiplying by 1. But when I distribute that to both terms, it's going to cancel out the fractions because I have like sine over 1, so I'd have sine over sine and cosine sine over sine, so it's going to cancel out that extra fraction. If you're confused about this part, make sure you write it down and I'll show every single step in class, but we're just getting rid of those common denominators and getting rid of our fractions and fractions, or complex fractions. So if I multiply it here, it's going to cancel out here, so I'd have cosine, and if I do it here, those are going to cancel and I'll just have 1. And the bottom, same thing's going to happen. So I'd have cosine plus 1. Okay. And now that we got it like that, it's pretty much where we want it. And you wouldn't know that until you worked on the other side. But we're going to let it rest for now and see what we can do on the other side. This is a lot more simple than we had it because we got rid of all those functions and now we're just left with cosines. Okay, so let's take a look at the other side. So what I see in the top is obviously a bunch of cosines, and we have a bunch of cosines here, but it's it's almost like a quadratic, which means we can factor. Okay, I know it has the cosines there, and you're like, oh my god, I have to factor with cosines. I know, seems crazy, but we're going to. So first, what I'm going to do is I'm going to rearrange it so it looks kind of like normal. So I'm going to put the cosine first. I'm going to leave out the theta because it's annoying. So we have 2 cosine plus 1. So I just rearranged it so it would be like x squared, x, and 1. At the same time, let's look at our bottom. So the bottom is sine squared, but everything else we have is cosine. So let's change that sine squared to stuff with cosine. So we know that sine squared is equal to 1 minus cosine squared. Don't forget that negative. We're going to have to distribute it in. Okay, so let's distribute first. So we'll leave this alone for now. Okay, and if we distribute that in, that'd be -1 and a positive cosine. So I'm going to put that first. Okay, so now let's get to factoring. The bottom one, we worked on factoring that down here. Okay, we did the same kind of factoring. It's a difference of perfect squares. So that would be cosine plus 1, cosine minus 1. And the top, that's like a quadratic. So if we rewrote it with x's, it'd be like x squared minus 2x plus 1. So how would we factor that? Well, what times to be 1 and adds to be -2? X minus 1 and x minus 1. So same thing here. So we have cosine minus 1 and cosine plus 1. Or minus 1, JK, both minus. So if you look at what we have, we're really, really close to what we got over here. Since we have a -1 and a cosine minus 1 in top and bottom, those can cancel out, and all we would have left is cosine theta minus 1 over cosine theta plus 1, which is the same thing we had on this side. So we did it. Okay, so that's it for today. We're going to practice a lot of these in class. I know it's going to be hard, but make sure you keep all your identities handy to help you with this.